The traditional approach for garbage collecting is challenging as there are some of the factors that cause the process become inefficient and ineffective. One of the important factors is they heavily rely on scheduled routines and routes, and this has led to increased operational costs. Besides that, inefficient garbage collection can impact public health and environment as well. Thus, we came up an idea of smart garbage monitoring system by utilizing the IoT and cloud technologies to monitor the trash bins, fuel level, temperature, and humidity in real time. The system will alert the waste management team when the bins reach predefined threshold and enabling efficient route planning. This system helps to improve the efficiency, reduce operational costs, and minimize the environmental impact. Last but not least, it provides valuable insights for decision-making and future waste management strategies.
Hi, my name is Wong Sikin. Now I will present the history of smart garbage monitoring system. The concept of a smart garbage monitoring system is not new and has been around for many years. Big Valley is one of the first applications of this idea in March 2013. They have set up 30 smart waste and recycling stations in Times Square. It can be used to compact waste, monitoring fuel level in real time, and send collection alert when reach the capacity. And then, IoT-based smart garbage monitoring is one of the projects carried out at University Technology Mara. This project uses ultrasonic sensor to measure the volume of garbage and the humidity level. The notification will be sent to an application called Blink if the capacity is full. The below figure is a demo of this project.
The future trend of smart garbage monitoring system. The future of smart garbage monitoring will be revolutionized by integrating robotics, drones, and microgrids. Robotics will automate waste collection with self-driving garbage truck and robotic arms that optimize route, reduce human intervention, and enhance worker safety by sorting waste. Drones equipped with advanced sensors will monitor waste facilities and landfill, providing real-time area coverage to detect issues like illegal dumping and ensure regulatory compliance. Microgrids will enable waste facilities to generate renewable energy from sources like solar, wind, and waste, achieving energy independence and reduce carbon footprint. Together, this technology will lead to a more efficient, environmentally friendly, and sustainable waste management practices.
I will present the problem statement. Firstly, the excess of garbage due to infrequent schedule of garbage collection could potentially lead to public health and hygiene issues. Second, fixed collection schedules or manual inspection often result in inefficient routes, leading to waste time and resources. Lastly, the existing garbage collection process causes environmental impact due to carbon emissions of the vehicles and also costly for the unnecessary petrol consumption and labor costs.
After that, I'll present about the objective and proposed solution of our project. The objective is to utilize an existing cloud computing platform to implement an IoT cloud solution that can track and manage waste level in garbage bins for efficient waste management. For the proposed solution, we are using Amazon Web Services AWS for our project to analyze waste data and generate reports on waste level and heat maps. These reports support public health efforts and can be generated weekly, monthly, and even yearly. The system will also suggest optimal garbage collection routes, notify collectors, and store all the data and reports in AWS cloud storage for early access for anywhere. Now I'm going to demonstrate the configuration of the AWS services of our smart garbage monitoring system. So this is the architecture diagram of our system, and it first start at the sensor. So for sensor, we simulate it using a Python code. So this is the Python code that simulates the sensor, which are responsible for collecting the data and then send the data to the IoT core with the specified topic. So when we click the run button, there will be 10 set of data sent to the IoT core. And then to check whether the data has been received successfully, we can check this S3 bucket to see whether our data has been received successfully. So we go to the console, we go to S3. The beans S3 is the bucket that stores those data that are collected from the IoT core. So today's date is 21. So in 21, we can see that these are the data that we just received. And then for this number is the ID of the garbage bin. And then next, when there are the data created in the S3 bucket, a lambda function will trigger in order to generate the data set that we use to create the report and heat maps and other diagrams in the Amazon QuickSight. So let's take a look at the lambda function. So this is the lambda function that will create the data set. We have placed the code here and also set the permission to allow it to create a data set in the IoT analytics. So the data set will be created in the IoT analytics. Yeah. So as you can see, the data set has been generated successfully. And then for this data set, we can use it to generate different kinds of report. So here, as shown some of the report that we have generated successfully in order to gain some insights. So for this is the diagram that's generated using the day dataset, which is the dataset that consists only of the data of a day. This one is the diagram that are generated using the week data. So after that, so these are the flow to generate the report for the user to view. And then not only that, our system will also calculate the optimized route. So similarly, when there are data stored in the S3 bucket, a lambda function will trigger to calculate the optimized route using those data. So we can see the lambda function. The lambda function use is same as the previous one because the trigger is the same. So yeah, similarly, we have also configured the permission and the code to let it generate the optimized route automatically. And then when the optimized route is calculated, we'll store into an S3 bucket. So we can go to the S3 bucket here and then see the route. This is the one that store the optimized route. So yeah, this is the optimized route that we have calculated. And then when there is a object stored in this bucket, this one, the one that store the optimized route, a lambda function will be triggered to plot the optimized route on the map. And then it will store in another bucket. So go back. And the map will be stored in this bucket, the route beans x3. And when you click inside, to view it, and you can see the route has been successfully plotted on the map. And then when there is a route has been plotted and on the map and stored in this bucket, another function will then be triggered to send a message to the garbage collector to notify them the route has been successfully optimized and plotted by using email, using the simple notification service. So this is the example of the email that we received by the garbage collector to view the optimized route. So yeah, that's all for the demonstration of our garbage monitoring system. Thank you.